I know what that is. All right. So I talked about this a little bit, I don't know if it was yesterday or the day before, about how a quadratic, when you take the derivative, it ends up being linear. And a cubing function, when you take the derivative, it ends up being quadratic. So this is the actual power rule. The shortcut. So we've talked about the different ways you can write the derivative, correct? So the derivative of x to the nth power would be the n would come down to the front, and then you would decrease the power by 1. Okay. So that's why the derivative of a constant is 0, because if I said f of x is 5, well, we can think of this in several ways. This is a horizontal line of 5. What's the slope of a horizontal line? 0. Or you could think of it as this is x to the 0 power, and if the 0 came down, what 0 times 5 is? 0, and it wouldn't matter what this was because that would be 0. But so what you should understand is that a derivative of a constant, which means just a number with no variable behind it, is 0. The way we would read this is the derivative with respect to x. That's what that d dx. Another way that you might see the derivative written is if you have the function written as y, you might see me ask for dy dx. Okay, so for today, if you can, you want to rewrite things as having a power so you can use this rule. And so how could I rewrite 1 over x? X to the negative 1 power. And so that's, for now, how I would rewrite all fractions. So x to the negative 1 power, if I wanted to find dy dx, the negative 1 would come down to the front. So it would be negative 1 times x. Now be careful. I have to subtract. What's negative 1 minus 1? Negative 2. And then the last thing is we go back and put it back in fraction form. That's negative 1 over x squared. Okay. So the general rule for having a constant or a number in front, so if I had a number in front of that x to the power, is we just leave that constant out in front and then still apply the derivative rule. By the way, you've now seen 3 ways that I can write the derivative, right? d dx, remember on the last one? dy dx, and then we learned already, I think I told you that the f prime x is the derivative. Okay. So for example, in this one, we're going to leave that 3/4 in there and use the power rule. So if I pulled that 3 down to the front, it would be 3 times 3/4 x to the second. And then let's simplify it. That would be 9/4 x to the second. And you can leave the x squared on the top of the fraction if you want, or next to. Okay, so the power rule is you bring this power to the front, and then you decrease that power by 1. So what's 3 minus 1 is 2.
So you're like mixing those.
I'm using this rule. Okay. Same thing, if you have a derivative of a group of 3 things, you just, and they're separated by addition, this changes when it's multiplication, because we have a special rule we're going to learn on Monday for multiplication. But when you have things that are separated by an addition sign, what you really, and you don't have to write this out, but really what you're going to do is you're going to do the derivative of, like here, 2x squared, and then where you're going to take the derivative of 5. So you just go piece by piece. And same thing if this was subtracted by two functions, and we can have more than two things added together as well. So what is the derivative of 2x squared?
4x.
4x. And what's the derivative of 5? 0. So you don't have to write that down. This just simplifies to 4x. Okay. So let's do some examples then. If y equals t squared plus 2t minus 3, especially in 3-4, we start talking about position graphs where we use t. So you can do this with different variables. I'm going to write dy dt, because the change in y with respect to t would be what? 2t plus 2. So just a second ago I had you rewrite these as negative exponents. We should probably we might need to do a little review for example 5 to refresh our memories. That when you guys see this, how could you write that as a power? Yeah. Okay, so if you see a cube root of x, how could you rewrite that? 1/3. Okay, you can also see things like this. Do you guys remember how you'd write this? 5/2. Yeah, don't put it away. Just ignore it. Okay. So that being said, then if these were on the bottom of fractions, those powers would be negative. So you might see something like this. It's written as a power right now, but what this really means is this is the same as 1 over the square root of x. Okay. So if you see things that are written as roots today, just remember to write them as powers. And then we are gonna practice putting them back in their radical notation though. Okay? All right, so here we go. So dy dx is -1/2 x. I'm going to show some work here. Then I have to subtract 1. So I'm going to subtract 2/2. Are you all okay with that? This simplifies to -1/2 x to the -3/2 power, doesn't it? So if I wanted to put that back into radical form, this negative just means it's going to be in the denominator, it's going to be raised to the 3rd power, and that's a square root. So we have -1/2, because of the half, square root of x cubed. All right, let's rewrite example 6. How should we rewrite that as a power of x? What do you think? Okay, so now we're going to apply the derivative rule. So negative 2 times 2/3 x. Negative 2 minus 1 would be negative 3. Now let's sort this out and write it back in fraction form. What would be on the numerator of the fraction? What would be on the denominator? What else?
Why is it
What's negative 2 minus 1? What?
Oh, why is it a negative? Why is it x to the negative?
Why is it x to the, can you say that again, Lindsay?
To the negative 2 power.
So, to use the power rule, you have to rewrite it as x to some power. This is on the bottom of the fraction. And I can't just use the power rule like on bottom of the fractions. It has to be like x to some power to use the power rule. And so if it's something is on the bottom of a fraction or something's a root, you want to rewrite it as a power. How are we doing? See all these trees are. Okay, we actually spend a lot of time on trig functions.
You show that again?
What's that?
Sorry, you show that again?
Back here?
Yeah.
Sure. I'm going to introduce this here, but we really will spend time doing derivatives of trig functions in 3.5. Okay. So, do you remember the other day where I had you use the underive and graph it, and did we see that the derivative of the sine was the cosine, and then the derivative of cosine is negative sine? Those, so far, these are just 3 shortcuts, basically, that you need to memorize. You need to know the derivative of the sine is cosine, and then the derivative of the cosine is negative sine, and then how to use the power rule. We will learn something called the product rule and the quotient rule on Monday. Okay?